You are listening to Season 4 of Future Ecologies.
Mountains are very special places, no matter how you look at them, whether it's recreation or it's biodiversity or it's human geography and human diversity. They're absolute, beautiful, wonderful places.
There's a world that's compressed along a gradient that is tangible. So you can see it, feel it. You can walk from a forest and be in the alpine tundra in 2 hours.
You get isolation plus time. You have places that are hard to get to, and they're hard to get to for a long period of time. And it leads to diversity rising in those situations. And so mountains are always really exciting.
Everyone who's ever moved through a mountainous landscape, that it's like it matters which direction you go, and you pick carefully the way that you move based on the topography of that landscape. And that's the same for every other creature that's moving, or every other biological or abiological process, wind, water, pathogens. And so those processes shape the change that we see, the gradients across those landscapes.
So even just over small little bits of space, like meters, we're not talking kilometers, you can have radically different climate conditions and totally different species in those places.
At every level, at every elevation, it's a completely different system. So it's a connected system, but you find a different assemblage of plants and animals and all kinds of other things, and it's all very immediate.
Because mountains are so difficult to move around in, they're often very undersurveyed. It actually turns out that we think we know lots about biodiversity, but if you go there at different times than when other people have visited a site, or you go to a place that people don't get to very often, you'll almost always find something new.
Something about being in the mountains and just the vastness of those landscapes and the hazards you sometimes see and experience, the friendships that are forged in those environments. I feel like they can weather a lot.
Yeah, as I always like to say, if you're lucky enough to be in the mountains, you're lucky enough.
Hey, I'm Mendel.
I'm Adam. And it's no secret that we here at Future Ecologies have an abiding love for the high country. Every year, I wait with mounting anticipation for that brief window, just a few months really, when the snow recedes and all of the alpine ecosystems just burst into life. In some ways, it's what I live for. It's a call that I find completely irresistible.
For many of us, mountains are little more than a backdrop for the rest of our lives lived here on the flatland. For some, though, they can be an intoxicating invitation to explore, discover, and self-realize. And for a select few, mountains can be a many-layered text that, if deciphered carefully, opens a window into the history of life, ecosystems, and the planet itself.
I mean, I mostly just go up there to see the wildflowers. What do you find most fascinating about mountains?
I love being able to look at the strata of rock and be able to peel back time. Mm-hmm. It looks unchanging, it looks immutable and timeless, but when you get up close, you can see all these transformations in Earth's history, all the tectonic, climatic, and evolutionary shifts that have literally determined the shape of our world.
Yeah. There's also mushrooms up there too, right?
I'm more than just the mushroom person, but yes.
Don't mean to paint you into a corner, Mendel.
No, that's okay. Today, we're gonna get elevated with some true mountaineers who are building on a legacy that spans over a century of incredible environmental change.
That's right. And they're going to tell the story in their own words.
From Future Ecologies, this is Mountain Legacies.
Broadcasting from the unceded, shared, and asserted territories of the Musqueam, Squamish, and Tsleil-Waututh, this is Future Ecologies, exploring the shape of our world through ecology, design, and sound.
Okay, so I'm Janine Ramtula, and I'm an associate professor in the Department of Forest and Conservation Sciences at the University of British Columbia. And what am I? I'm a landscape ecologist by training, and I'm really interested in large landscapes and how they change across space and through time, and who the people are in those landscapes that are shaping that change and making decisions about how we want to live on those landscapes into the future.
I've always wanted to be Janine. I'm Eric Higgs. I'm a professor in the School of Environmental Studies at the University of Victoria.
Longtime listeners will remember Eric from the Nature by Design series that kicked off our 3rd season. He's a friend, mentor, and now my colleague at the University of Victoria. And he also helped us produce this story.
A story which begins way back in 1996 in Jasper National Park, high up in the Canadian Rockies.
I was a graduate student at the time. I was a master's student at the University of Alberta, in the Department of Renewable Resources, of all awful names, and doing a graduate degree, and I wasn't very happy in that graduate degree. I hadn't yet found the project that really made my heart sing, and I was actually ready to quit, to be honest. And then I was kind of casting about at the university, just trying to find somebody that was doing interesting work that felt like it was the right fit. And somewhere along the lines of knocking on doors, I knocked on the door of Professor Eric Higgs, and he just started talking about this project that he was putting together, the Culture, Ecology, and Restoration Project in Jasper. I don't even remember what we talked about. I just remember being blown away by the interdisciplinarity of it, the way that he was bringing together people from all different disciplines, different perspectives on a question, what does it mean to do restoration in a national park? He said, your job on this project, what I want you to answer is, what did this national park look like 100 years ago? And the idea was that we were going to recreate kind of the ecological history and the cultural history of the park and bring those together to ask about how the landscape and the people in that landscape had changed.
It was way more challenging to answer that question than we ever expected it to be. So we thought that was the easy part. We'd walk in, we'd go to the archives, there'd be some books, book chapters written about this, and that we'd be able to piece together kind of what the landscape looked like. We got quite desperate after the first few weeks, right? It's like, and we were having a dinner, I recall, around the table with a group, and I just said, we have really got to go out, and everybody tomorrow has got to figure out, can we find anything that tells us what this is like?
We thought about using dendrochronology, so you can core trees, but that's very painstaking and you can only do it in small areas. So we'd looked, for example, for old historical air photos, right? That's always a standard place to go, but the earliest air photos were from the 1940s, and so that got us back part way, but not the whole way. And so then, I remember the day that I'd gone in and was talking to some of the wardens, just saying, I'm looking for old photographs or old something, anything that we can use to reconstruct what this place used to look like. And he said, I got these old photographs in this desk drawer. And so walks me over to the desk drawer and he opens up the bottom, and then there's these just beautiful albums of pictures. And you would go page after page, black and white, and they were kind of by maybe 5x7 or 6x4, and beautiful pictures. These kind of cryptic numbers in the upper corner where you could tell there was some kind of series or something. Front ends of the books had this little index in them that had station numbers. So they were something, but it wasn't quite clear who had taken them or what they were. And they had a date in the corner, 1915.
That's about all we knew about them.
That, and I remember that map. It was like an 11x17 map, and the map had numbers on it. And at some point, we put together that the numbers on that map matched the numbers that were in these albums. And we were like, those are the photo stations where we would need to go to take those pictures. And I think you were the one that said we should go repeat them.
So we sort of scrambled up to Powerhouse Cliff. We found an old animal trail and we followed it up. It wasn't very difficult to get up there, but we walked along the ridge of this cliff and, holding these historic photos out. We took photocopies, right? Mm-hmm. Yeah. And we got up along the ridge and we kept looking, and it was like we weren't finding the right spot. And then eventually it was like, oh my gosh, this has to be the right place. And then we looked out across the Athabasca Valley and nothing made sense. And you described it as a kind of vertigo. Like you have this interpretive vertigo where you're in the right place, looking at a photograph of that place, and then what you're seeing isn't anything like what it looked like.
There were trees. Everywhere we looked, there were trees. There was this huge carpet of green trees, tall trees, thick, homogeneous trees, right? And that's what we expect in a national park. That's what we come to know Jasper National Park to be, is trees, right? Because it's a protected area. But when you look at the pictures of this patchy mosaic of all of these different little shrubby things, and there's some grass areas, and then there's trees of different types and textures, some coniferous trees, some deciduous trees, different heights of different trees, like just a mosaic of diversity. So here you are standing in the middle of a national park, which has been preserved intact to be the way that it's supposed to be. And yet we're standing in the same spot that these surveyors were 100 years before. And the park is fundamentally different.
So then we just walked away and left it all alone. No, we started walking and we did a couple more stations. And then having the mathematical mind that you do, you started to think, maybe I can actually reconstruct the vegetation patterns from these oblique photos. Wouldn't it be cool if we could repeat all of the images in Jasper National Park? And so we started getting all enthusiastic about this idea because we now knew there were 92 separate locations, and from each location there were multiple images. So there were a total of 735 images. And most of these were mountaintops.
Never imagining that this would become bigger, right? We just thought this was this one survey. We focused our work on just this one space. So those were the pictures we were repeating.
The story that's etched in my mind so strongly is the very last day of the second summer of this work, where we were wrapping up the last station. We saved Pyramid Mountain for the last, and that was the very first real mountain that Janine and I climbed. But by this point, after 3 years, we were pretty fit and used to mountains. We shot the last photograph, and I had a bottle of bubbly stashed away and some smoked salmon, and we watched the ravens circling, and we had just a wonderful time. I don't think I would recommend champagne on a mountaintop when you have to climb down as a life choice, but that was what we did. And we got off these big quartz boulders and down to where we were staying, and there was a package for us. It was from our colleague Ian McLaren, who is an historian, literary historian at the University of Alberta, an amazing archival researcher as well. And it was the season-end survey report from Morris Bridgeland, who was the surveyor. We knew the Bridgeland name really well. And it was his report to the federal government on his 1915 survey in Jasper National Park. So at the very last day, the last moment of our survey, we finally knew where they had gone and in what sequence. And it was fantastic. We read the whole thing as we were eating dinner and reading it. It was oh my gosh, they did this. And turns out they had 2 camera crews, which is how they managed to go get through all the photography in one season. And then we both kind of moved on from the project. And we thought, yeah, well, this is our moment. And then enter Rob Watt.
I go by Rob. There's too many Bobs in the world.
At that time, he was a park warden in Waterton Lakes National Park, and he was an inveterate historian, amateur historian.
And for some reason, there were something like 36 volumes of Morris Parsons Bridgeland's photographs on a shelf in the common area of the office. And I didn't understand the background at the time. I didn't even know who Morris Bridgeland was. I gathered from the book that he was a land surveyor and he took a bunch of photographs, but we didn't have any of his maps, for instance. And of course, this is way before there was anything like an internet. They had a big map collection down in the admin office in Waterton. So I poked around in their map collection. And lo and behold, there's a map of Waterton, 3 map sheets with Morris Parsons Bridgeland's name on them and camera stations.
And he said, I have maps that show, where there is evidence, photographic survey locations, because it shows it on the map. And it turned out to be by the same surveyor that we were working with in Jasper, Bridgeland. He said, and I have the index to views, which was all important because that tells you where they were. I mean, the names aren't always modern names, but at least you knew where they were. But he said, but I don't know where the photographs are.
And so Eric contacted us in about 2002, very interested in where those photos came from and was there a bigger collection.
Jill Delaney, lead archivist in photography in the Private Archives branch at Library and Archives Canada.
I've actually been working with Eric for 20 years on this project, and I've only been at the archives for 25 years, so it's been a big part of my career.
And that's too long a story to spin, but we found out that these glass plate negatives were held in boxes at NRCan, Natural Resources Canada, not in the National Archives. And they were actually, in a sense, lost. I have this story, it's probably not accurate, but I like it anyway. It's a bit of a conspiracy tale that some benevolent civil servant realized the value of these images and misfiled them. We did come across records, and it's basically a destruction protocol. They were held on too long, they take up a lot of space, they're heavy, nobody uses them, they're gone.
3 grad students from the U of A went to Ottawa to one of the national repositories where records go to die, essentially.
And they were walking along, and just by accident, I think, out of the corner of their eye, and poking out from the bottom of one of these barcode tags was a number that matched the kind of sequence of numbers that was on the box. And they said, whoa, wait a second, can we take a look at that box? And pulls it off the shelf, super heavy. And it was filled with glass plate negatives. So were the rest of the boxes on that shelf.
Lo and behold, they found them.
So these are what's called a half plate, about 4 inches by 6 inches. It's a relatively thin glass plate, a bit thinner than window glass, let's say, but not much. It's kind of the same as with a film negative. It's basically the same concept. It's just that instead of the emulsion being on the film, it's on glass.
All right, so our cameras, in the age before digital, our cameras used to use film. And when a camera took a picture on that film, it would make the image that it recorded on the film was like backwards of what you actually see. So in places where, if you're using black and white film, where something was dark in real life, it would be light on the negative. And where it's light in real life, it is dark on the negative. And you only get to see back what that real picture looks like when you put that negative onto a piece of photographic paper and shine light through it, where it reverses that image again and it ends up looking like what it really looks like in real life. So if you're looking at the negative, your eyes have to kind of imagine the whole thing backwards. There's maybe 100,000 glass plate negatives in the National Archives covering most of British Columbia, and they are spectacular images. These were the photographs that surveyors were taking at the turn of the century to make maps of this area.
The government was worried about American expansionism in the 19th century. So they started doing a boundary survey between the US and Canada in the 1860s.
The original surveyors, in the most case mountaineers or geologists, who were hired by the government of Canada or by the provinces to create these maps.
This kind of topographical survey. The problem was that when they hit the mountains, they realized that doing a kind of standard rod and chain survey was going to be really difficult, really slow, and really costly, and probably impossible in some places.
The traditional means for surveying land was to establish reference points in the landscape, and then from those reference points, using fixed distances and elevational measurements using transits and so on, you would get a sense of the topography, the elevational change, and the distance. So you could create pretty accurate maps. So if you're moving across Saskatchewan, or what's now Saskatchewan, not so hard. Tedious, but not hard.
Yeah, it's like having a tape measure.
The Gunther's chain.
So the chains were part of a legally determined length.
66 feet long, divided into 100 links of approximately 9 inches per link.
And so that was why when they came to the mountains, like you can imagine dragging your chains across the mountains.
Like, oh, now we have this really steep elevation and we've got all this complexity around topography. And to do that using traditional techniques is hugely laborious.
So what they would do is they would go to a mountain peak, they would level the camera, and then they would take a whole panorama around to look at all of the peaks that you could see from that one peak.
So let's imagine that you have 3 peaks, A, B, and C. So you'd get to peak A, you'd build yourself a nice big cairn, and then you'd take a set of panorama images so that you could see peaks B and C. Then you'd go to B, build yourself a nice big cairn, and then you would shoot back so that A and C are in your panorama set. Then you'd go to C, build yourself a nice big cairn. You'd say, well, why the heck did you put a cairn on C? Isn't that extra work? Yeah, you're going to D, and D is going to tie back to C.
And all the way through the mountains.
It was a very calculated process. I don't think that it was done with artistry in mind, but the result is that some of the photos are
absolutely beautiful, but that's also just the nature of the landscape and the subjects that they're taking pictures of.
It's not a tourist camera, right? It's a technical camera that had to survive the rigors of hiking and climbing through the mountains.
And that's what they were carrying around. They had these big boxes on their backs that would hold 12 glass plate negatives and this old camera. And so imagine climbing mountains with like a backpack filled with pieces of glass in it.
It wasn't nearly as cumbersome as some earlier processes where you had to take all the chemistry and a darkroom with you. But probably the equipment weighed about 40 pounds that they had to take up to the peak where they would actually do the photography.
And so, yeah, climbing a mountain is hard, but if you can climb a mountain and take pictures and take your pictures again in this 360-degree circuit going all across, you're taking a picture of all the land that you don't have to drag the chains across.
And it dramatically shortens the amount of time the surveyors have to spend in the field. And then you could pack all of these negatives together.
And then they would send them back to the office in Ottawa, where they must have had whole office fulls of people doing geometry, essentially, right, to turn those oblique angles back into a proper topographic map.
The mass is fairly complex. Of course, they had some pretty smart people working on it.
Our earliest topographic maps of, certainly of the mountains, but of much of other places in British Columbia were done with this kind of technique. But 100 years later, like, we look at the pictures, and to have to turn those into top-down maps it's just become an art that we've lost. Like, we just don't do it anymore.
And so began the Mountain Legacy project, leveraging this massive collection of historical photographs, over 100,000 pictures covering almost all of BC, part of Alberta, and the Yukon, to reveal over a century of change.
And to do that means repeating each and every photograph on each and every mountain peak, one by one.
Okay, you have a photo. You go to the place where that photo was taken. You point your camera in the same direction. You try to take the exact same photo.
People who have done this a lot, so we have field crew members who have worked with us over the years. There's always one every summer who's kind of like the station whisperer, who does the research with the photographs ahead of time before you go out into the field and gets a sense of, whether there's one location or two where the historical surveyor shot from, and then they just have a sixth sense, a pattern recognition that allows them to say, I think it's over there.
Because basically you're going out and you're triangulating the reverse of what the surveyors did. They knew where they were. We're trying to figure out where they were, so we're backtracking from their photographs.
I know I have not been the only one that has been on the wrong mountain. We don't do it very often, but once in a while.
Well, it speaks to that it's an art and a science to find your right location.
Yeah, with a little bit of mountaineering thrown in as well.
You've heard from some of them already, but now it's time to meet a few members of the MLP field team.
Well, age before beauty, I guess. So I'm Mary Sanseverino, and I am a retired member of faculty, the Department of Computer Science at the University of Victoria, Faculty of Engineering. And I've been a member of the Mountain Legacy Project since 2010, and still do a little bit of work with them from time to time.
I'm Jenna Falk. I was involved with the Mountain Legacy Project from 2011 to 2014, roughly, while I was doing my master's in the School of Environmental Studies at UVic.
And when I went in the field for the first time, I went as Jenna's assistant.
Which still does not make sense to this day.
Oh, it makes great sense. Great sense to me.
Mary kept us alive.
So fieldwork was incredible. My name is Julie Fortin. I did my master's with the Mountain Legacy Project at UVic, 2016 to 2018. I joke with my fellow MLPers that I peaked too soon and I will never have another experience like that.
So I've almost been 10 summers in the Rockies now because of this project. My name is Kristen
Walsh.
First became involved with Mountain Legacy in 2014. Went out for a stellar field season with 4 amazing, strong-headed women. What we do in terms of our work is very different from mountaineering, because often people get to the summit and then beeline it down to get to the sauna or a beer with friends. But our work really begins when we arrive on the summit.
You know, we work with these surveyors, we work with their work, and you're so close to this work that really you feel like you know the person.
Because they all have a signature in their photographs.
Bridgeland, that man was fearless. Every time we were doing one of his sites, I had this sort of like low-key dread because I just knew that wherever he set up that tripod, you know, it was going to be not always the most like low exposure zone. It was going to be right on that outcrop, right over that precipice, just to get that perfect angle and perfect shot. And we knew we were in for it that day.
My name is Sandra Frey. So I worked as a field technician in the summer of 2016 and 2017.
And finally, Alina Fisher.
I am a PhD student in environmental studies. I'm also the research manager for environmental studies, so I kind of wear two hats.
It's so cool to be kind of walking in their footsteps. And even some of our techniques are very similar to the techniques that they used back at the turn of the 20th century. And their maps are, for the time, pretty accurate.
Very accurate.
There is a somewhat of a science to it, but there's a good dose of intuition as well that's hard to explain unless you've been there doing it. And sometimes you'll just arrive at the top and you can imagine where someone stood 100 years earlier, or sometimes there's a physical cairn that they built.
Huge cairns,
huge
like,
cairns.
you know, some were 8-10 feet tall, massive things.
Yeah.
And you need to snuggle into that cairn to take the picture. And sometimes the obvious spot is not the spot. And you'll spend hours. So definitely a lot of patience needed in lining up those photographs.
That was always like our kind of type A personal challenge in the foreground, is like, how close can you get the foreground to match exactly? And some of the rocks were in the exact same place.
Same place, yeah.
I know, I'm always wondering, like, can I sacrifice a little bit of scientific accuracy right now not to get attacked by wasps? Is this okay?
Isn't the verdict shh?
Yeah. The verdict is safety first.
Yes, safety is always the first.
So I was, well, not recently, but a few years ago, I was on Eiffel Peak in Banff National Park. And Arthur Wheeler was there 1903, and he built an 8-foot cairn. The cairn is still there. The pin that he put in place is still there. I know because we were there in an electric storm and the cairn started to sing at you. When that happens, you must leave.
One of these hazards that you're on the lookout for in the mountains is weather, primarily. It can be a beautiful day. Mountain weather will do what it does best, and it changes on a dime. There was one day where we were on a peak and we were very focused on the photographs we were taking.
We're going about taking our pictures, la-di-da-di-da.
And there was a storm cell that caught us by surprise.
I don't really like the look of those clouds.
And of course, with the storm cell came all of a sudden hail that's pelting down on us, and everything got slippery. And because it was a heli drop-off, full hover exit, you know, just right on this sort of conical peak, we had a really hard time climbing down a little bit, not to be the highest point on that mountain.
And then we looked at each other and we saw that our hair was standing on end.
There's certain times when you just don't want to be on top of a mountain. Not only do you not want to be, but you shouldn't be.
You could just really feel the static in the air. And I remember hearing these boulders next to us where we were sort of crouched, just could hear them buzzing.
You can hear the static in the rocks.
Sort of like in between a cat hissing and something like sizzling in a hot cast iron pan.
Everything that was metal, from the pin on top of your ball cap, you could hear that kind of singing, and it felt very real in that moment.
So that was a learning experience. Always keep your eye on the clouds.
You know, I like to say when you go to the mountains, nobody died, nobody cried. Well, nobody died.
Some of them were happy tears, to be fair.
Very happy tears, especially going, yes, we made it.
Yes, there are tears of joy and then there are tears of relief.
There's so many moments, but they were fun at the time, weren't they?
I feel like it's type 2 fun because at the time you're struggling, you're slapping yourself nonstop. You keep the mosquitoes away, and sweat's dripping in your eyes, and your hair got tangled in a bush as you're walking past something. You're hungry, you're thirsty. Oh crap, my 3 liters of water is not enough.
I feel like the most fun I've had on these projects and in generally is those times I'm also asking myself, whose idea was this?
Yes.
Like, what are we doing here? And then later you're like, that was so much fun.
Type 2 fun.
Because it's fun when you look back on it.
Yeah.
But at the time, there's a bit of swearing involved.
Yeah.
Yeah. I've also invented type 3 fun,
which is never fun.
It's mostly what you deal with the offices of don't quote that.
All in all, this does not sound that different from my bad mushroom trip at the top of Black Mountain back in 2010.
But did you come back with a priceless data set of thousands of repeat photographs?
No, I did not. I was just happy to make it off the mountain alive.
Well, now that we too are coming down out of the mountains, let's have a look at those photos, shall we?
We shall. After the break. Adam.
Mendel. This is Future Ecologies. And today, we're hearing about the Mountain Legacy project from the folks that made it happen.
In this second half of the episode, we ask, what can we learn from 2 sets of identical photographs taken over a century apart?
We have this remarkable and very rare collection. It's very unusual to have data that's this old in North America. This remarkable collection of what landscapes looked like over 100 years ago. Aesthetically, it's really neat to see that, but from a point of view of a scientist, this is very difficult to get data.
Brian Starzomski, director of the School of Environmental Studies at the University of Victoria.
There are no other ways to get data like this. There are no other ways to look this far back in terms of what landscapes and what the ecology of the West look like.
The fidelity of the information that are on the historic glass plates, it's hard to beat that. Now, mind you, it's an oblique view.
Interpreting oblique photos is more difficult than interpreting photos or data that's collected at a right angle, which is what satellite-derived or remote sensing data is.
And I can tell you, as a person that does a little bit of software, it's not easy to go from the oblique view to something that goes on to a 2D map that goes to the orthographic, the look-down view, like an air photo. You can do it, but it's not easy. So in the photograph, the pixels that are in the far distance, those pixels are huge. And the pixels that are in the foreground, those pixels, they represent a very small area.
If I were to tell you that, like, there are 1,000 pixels of coniferous forest, it actually kind of matters where they are on the photo, if they're in the foreground or the background.
So in the distance, 1 pixel, huge area. Foreground, 1 pixel, tiny area.
This whole process of projecting these photographs is actually computationally pretty difficult, but doable now.
It's applied linear math and a lot of programming. And we wouldn't call it research if we knew what we were doing. So we're really, really at the bleeding edge, if you will. What we do with this is take land cover classifications that are made from the photographs. So imagine you're looking at a photo that was done in 1897. And you look at the photo and you classify it and you say, well, that's grassland and that's
mixed wood forest
and coniferous forest,
open meadow,
shrub,
barren rock.
That's ice. And then you do that for a modern photo. And then you compare the two.
Yes, that's when you get into the analytics side of things. And it's not just all fun and games in the mountains. I've heard.
I've got a couple of takeaways. Number 1, loss of ice. The loss of glaciation is absolutely jaw-dropping, staggering. Second, industry in the landscape. Several times we were on the land trying to line up these images and everything worked except for one, and that's because the mountain wasn't there anymore.
Probably 5% of British Columbia's GDP comes out of coal mines. Coal mining is done by mountaintop removal.
It's really crazy to see the glacier gone, but when your underlying geological structure is just gone, it's disconcerting. And I'll say a third one, alpine treeline ecotone creep upslope. So that is in so many photos.
When many people think of the tree line, I suppose they probably think of this razor-sharp delineation between forest below it and then alpine tundra or wildflower meadows above it. And it's often not really like that.
As you get closer to that boundary, which we call the tree line ecotone, the trees start to change their growth forms.
Andrew Trant, Associate Professor in the School of Environment, Resources, and Sustainability at the University of Waterloo.
And so you start to get trees that are growing less vertically, more horizontally. The growth form that we refer to is called Krumholtz.
Krumholtz, these trees that are very difficult to walk through. You see them in mountainous places all over the world. The conditions are such that they can't grow very tall, certainly less than 2 meters tall.
You can have the same species growing in the forested area that you see up just around the edge, and one can be 100 feet tall and one could be 3 feet tall. Same species, but it's just the environment that really drives that growth form.
And it's just this impenetrable thicket that is very difficult to get through, but absolutely filled with bird life. When we measure tree lines, we do it in a variety of different ways. We may say that a tree line is the highest elevation that a certain height of tree goes. We might say that this is where the 2-meter trees run out. Or we might say that the tree line is the limit of where a certain density of forest exists.
One important piece of this puzzle when we're thinking about these boundaries and thinking about tree line is that they are in some ways controlled by temperature. So as things are warming, then we would expect trees and ultimately this whole complex community to be able to grow higher up the mountain. In most cases, that's what we saw. It was kind of an overwhelmingly clear signal of change in that direction.
For all of the quantification that we've done and being able to transform these into kind of like hard numbers that we always like to have as scientists, I still think that some of the most value comes from these pictures is their evocative value to audiences, to be able to look at those pictures side by side and to just be able to see the amount of change in a landscape. And then to be able to dig in and ask these questions like, okay, so these landscapes are completely changed. First of all, which one do you think is the present and which one do you think is the past? And so often people say, oh, well, the one that's got trees everywhere, that has to be what it looked like 100 years ago. And the one that's patchy and's got like little shrubby stuff, that must be what it looks like today because we've obviously cleared the land, right? It used to be treed and now we've cleared it because that's, again, our image of what people have done to landscapes. And it's bad if there's no trees and it's good if there's just homogeneous trees everywhere.
Yeah. A lot of people that I have spoken to have said, oh, more trees, that's good, isn't it? And in fact, no, especially a lot of the places where there are these denser forests now have a lot higher wildfire risk. And so that's risk to the community, a whole bunch of other risks for climate change, because if you have these large swaths of connected forest, it's a lot harder to fight these fires if they do get into places that we don't want them to be. It's also bad for biodiversity in the sense that because the landscape is more homogeneous now, species that relied on these diverse bits of habitat have less of it, and therefore they're suffering, whereas species that were already dominant are doing better.
And in a mountain environment, you are limited with the amount of area that you have. As you go higher up the mountain, the area decreases because you're looking at something that's kind of conical.
That's right. And actually those alpine meadows, those mountaintop meadows above the tree line are some of the most remarkable and diverse habitats for a variety of very rare plants, often with very restricted ranges because they're just found on those mountaintops, or hugely diverse and abundant butterfly populations. So one of the really remarkable things about being on a mountaintop in July or August are the thousands of butterflies flying around. And as tree line moves up, those habitats get smaller and smaller. And this is going to happen all across southern BC. Tree lines will move up. We'll have more trees, sure, in mountains, but we'll have much less alpine habitat, which means much less habitat for things like whitebark pine, for really beautiful, rare and endangered butterflies, for really rare and range-restricted plants. And just that habitat that we really love. A lot of people really love those lush mountain meadows or those rocky, craggy peaks, there are going to be fewer and fewer of those as forests move up more and more in the mountains.
The pressures that are being put on mountain landscapes, it affects our water, affects our air, our culturally important and sacred places, but probably most of all, it affects our wildlife. Gradually, they are being squeezed out of their habitats.
Bill Snow, Acting Director of Consultation for Stoney Tribal Administration.
I work with the 3 First Nations that comprise Stoney Nakoda, which are the Bearspaw First Nation, the Chiniki, and the Goodstoney First Nation.
The reserves of these 3 nations are just west of Calgary, a few hours' drive south of Jasper, and near another famous national park, Banff.
You drive through the Rocky Mountains, oh, isn't it beautiful? But then the flip side of that is this has all grown in because fire has been suppressed for decades. And what does that mean for wildlife and ecosystems? Fire would be naturally occurring here if it wasn't put out as soon as possible. So the ecosystems have changed, the wildlife patterns and habitat has changed.
When fire is excluded, we get what we have right now. We have overgrowth so that even wildlife can't find access into some areas. That may bottleneck wildlife routes to go into certain areas where they may come into more human conflict. And then those overgrowth areas then become tinderboxes for natural or man-made events to become fire hazards.
Yeah, working in, say, the front ranges of Waterton, where you're aware of mountain pine beetle as an insect pathogen, and then fire suppression, and then the desire now to prescribe fire and put fire back on the landscape, and so many other drivers of change, shifting that ecosystem around. And then you get these events that just leave you breathless. So in September 2017, a wildfire came in over the Continental Divide into Waterton. Fortunately, the National Park staff had done early warning on this fire and managed to evacuate people and so on. But I've heard some describe it as a slow-moving explosion. So the fire came in, in the early evening, and by midnight it had blown through the park. Took out over 35% of the park area in that period, and a lot of it at very high severity, meaning the fire really, really burned hot in that area. People were frightened by that fire. I mean, people were traumatized by that fire. It was so severe and so fast-moving. And so it was a kind of a system-changing event, and clearly one that had been, in a sense, unprecedented.
There is work going on within Banff National Park, fire breaks, fire smart programs, and that's good. But this whole policy of no burning period over the last 100 years is creating a large problem. And that's going to affect everybody from people who visit the park to the people who live there. And as Stoney Nakoda, that's part of our traditional lands. So it will impact us as well.
This speaks to something that you have to come to terms with if you're going to work with these photos. These photos are colonial artifacts. They are deeply colonial. The reason that they exist is because the country needed to make maps. And what did they need to make maps for? They needed to make maps so that the resources could be divvied up.
The images are arguably a preeminent colonial record. They were about surveying for resource extraction, surveying for transportation, and surveying for settlement. So they were really all about exclusion of Indigenous peoples.
On this idea that people are necessarily bad, we get rid of them, and now we got the park and we're protecting it.
So, yes, very effective from a colonial perspective, but also very effective in producing a lot of images that we might be able to use for decolonial purposes.
And so how might we do that? Well, what about using them to inform First Nations studies of land? Maybe, returning to burning practices, for example.
In traditional times, I believe that traditional burns were used in select areas to regrow areas for purposes of harvesting, not only plants and medicines, but for wildlife. and was also used to clear pathways, to create access.
Right, and here were these photographs that showing, well, oh gosh, look, like this park that we've protected, here I'm using scare quote, protected for 100 years, and look, it's fundamentally changed. And why is this? And it's forcing us to consider what's causing this change, what was maintaining the ecosystems that looked the way they did 100 years ago. And oh, look, it was actually people taking care of these lands that made those lands look like what they did.
When the Stoney people would travel through different areas, they wouldn't go and cut down a brand new tree, a green tree. They would use the deadwood in that area. So just by living and camping in a certain area, they would take all of that away from that landscape. And they would always be moving around. So they'd go from one area to another, and another clan or family might be behind them doing the same thing. And so you had this maintenance going on just by Indigenous people moving through those areas. But you don't have that anymore. We have been in talks with Banff National Park on reintroducing Indigenous burning. Not all areas, but select areas. I'm not saying that fires are going to solve everything, but those past practices held those areas in a certain kind of a balance.
And, of course, humans and fire are not the only ecosystem forces at play here. The historical dynamics of these mountains also included large, grazing mammals, like bison.
We see that by having wildlife like bison out there, they are able to impact that landscape. They are able to feed on not only the grasses, but the willows. They rub up against the trees when they move around. They trample down on the new growth that comes up. When bison are out there, they hold the forest in check from overgrowth. They make trails through willows and through the bush to get to the places that they want to go to. And so they have an impact on the landscape that we don't totally fully understand yet. Stoney Nakoda have been in support of the bison reintroduction project going back to 2014. They were translocated into what's called the Panther Dormer area, sort of the northeast part of Banff National Park. There's no roads to get in to this particular place, so the bison had to be airlifted by crates in helicopters 30 kilometers into the actual reintroduction zone. They've gone from 16 head in 2017, and today they're over 90 head. There's a lot of overlap related to wildlife studies, related to fire, related to land planning, especially in Banff National Park. Landscapes today are drastically different from how they looked 100 years ago. So that's really important to know.
But beyond revealing those changes and offering some tools to intervene, these photos can play a part of an even more fundamental question.
Stoney Nakoda Nation have used the images to sort of say, well, what were these mountains called before? And let's rename them. Let's at least get them into cultural currency.
Those places have a story and a name that hasn't been told yet. It's important because many of the places, especially in the Canadian Rockies, do not reflect the Indigenous name or the Indigenous meaning. One of the first pictures that we were able to work on with the Mount Legacy project is the first picture from the east side of Lake Louise. And yes, it is a beautiful place, but it's also a spiritual place. And that's not what visitors understand when they come there. Lake Louise, it's the crown jewel of the Canadian Rockies. And The person who's credited with the discovery of Lake Louise is an early mountaineer named Tom Wilson. August 24th, 1882. Tom Wilson was working on the railway when they came through that area. And at different times during the day, they could hear like a big rumble off in the mountains, like an avalanche or a rock slide. There was a group of Stony people camped nearby in the Banff area. And so he went to go visit them and asked them, what's that sound, that rumbling sound? And they told him that that's God speaking to us. And so he got all intrigued. Well, where is this place? I want to go see this place. So one of the guides, his name was Edwin Hunter, a Stony guide, and then he took him up there to go see the lake. And when they got up there, you could see those rock slides. So Tom Wilson was guided up there by a Stony, but he's credited with the discovery. So if places and names have meaning, we're not communicating that meaning. We were able then to take that photo and then add in the Stony name for Lake Louise, Hara Juthin Imne, which is the Stony translation for Lake of the Little Fishes. We thought that had more meaning and more reflective of what that place is. So when we have a chance to say, yes, this is Hara Juthin Imne, that tells us that there's fish in there, small fish, and that there's also additional names in that area that we haven't got to yet. So I'm talking about Mirror Lake and Lake Agnes and other peaks in that area. It's really meaningful to be able to get to work on these types of images within the Stony Nakota territory. The images have been used towards a process of colonization. So why can't we use those images towards the process of indigenization? It's taken 150 years to get to this point where we can relay some of these images. But now people know.
The images are open to anybody who wants to use them. We built this custom database we call the Mountain Legacy Explorer, and it holds all our historic images and all our repeat photographs. We collaborate with the National Archives in doing this. And so that's been a big commitment for us, is to daylight these images to make sure that people can get access to them.
And then not only do we have that as a tool, but then it speaks to us now to say, what are we going to do about it? Are we going to take all those images and put them in nice frames and keep them on the shelf? Or are we going to take what they're saying and apply it? Is that something that can be impressed upon regulators and government to say, this is how we need to be imagining landscapes towards. This is how we need to be providing access for wildlife.
You know, we're fascinated with change at the same time as being really afraid of it sometimes. We don't like change, but we also love to study it, whether it's one day to the next in our flower garden or 120 years to the next in a mountain pass. And through these photographs, we have such a unique perspective in the Rockies to see that long-term change that we don't necessarily in low-lying areas. So I think it's for anybody to recognize that landscapes change for many reasons and they're going to keep changing. And with climate change, there's a sense of loss when we lose the landscapes that are familiar to us. But there's also, I think, a good reminder in these photographs that we have an opportunity to support species and ecosystems through that inevitable change.
And if you'd like to dig into that long-term change for yourself, you can explore all the photos
and all the data
of the Mountain Legacy Project at mountainlegacy.ca.
It's actually really cool. You can slide back and forth between the historical photo and the modern day photo and see the changes on a really, really detailed level.
Yeah, and they're beautiful.
They are beautiful. This episode was made possible by a Pathways to Impact grant, mobilizing knowledge in support of the United Nations Sustainable Development Goals.
Specifically, those pertaining to clean water, climate action, and life on land.
And of course, The Mountain Legacy Project itself wouldn't have been possible without all of the people that you heard here, and many, many more.
So thanks to Eric Higgs, Janine Ramtula, Rob Watt, Mary Sanseverino, Jill Delaney, Andrew Trant, Alina Fisher, Brian Starzomski, and Bill Snow.
And the amazing field team alumni, including Julie Fortin, Kristen Walsh, Jenna Falk, and Sandra Frey.
Plus everyone who we didn't get to speak to. Rick Arthur, Ian McLaren, Navarana Smith, and countless others. Grad students, helicopter pilots, archivists, etc., etc.
Future Ecologies is a completely independent production. So thanks, as always, to our patrons who support this show. To join them and get early episode releases, extended interviews, and other bonus content, including access to the best Discord server on the web, go to patreon.com/futureecologies.
This episode was produced by me, Mendel Skolsky.
And me, Adam Huggins.
With music by Thumbug, Eric Tuttle, Shadow Acid, Sage Palm, and Sunfish Moon Light. Okay, see ya.